Hello friends, this is fourth part in Aldehydes and Ketones chapter. In our previous session we have studied about the physical and chemical properties of aldehydes and ketones. Today we shall continue the same chemical properties. We have studied in our last class the chemical properties. Only one chemical property has been studied. Today we shall study the other chemical properties. The second chemical property in aldehydes and ketones is reduction. It is reduction. What do you mean by reduction? Reduction refers to addition of hydrogen, or else reduction also refers to removal of oxygen. So what happens when aldehydes and ketones are reduced? The first reduction is reduction to alcohols. Under this, the first reduction is reduction to alcohols. Whenever any aldehyde, if it is reduced using reducing agents like, remember these reducing agents: lithium, aluminium hydride, or sodium borohydride, or catalytic hydrogenation. This means hydrogen in the presence of nickel, platinum, or palladium. Choose any one of the three, and any one among these three, either this one or sodium borohydride or catalytic hydrogenation. Out of the three, you can choose any one as the reducing agent. I have told you in my previous chapters also that whichever reducing agent you choose, the way you represent them here is also important. If you are choosing catalytic hydrogenation, then you are supposed to write H2. On the arrow mark any of these catalysts, either nickel or platinum or palladium, any one would be enough. If you are writing an aldehyde which is getting reduced by any of these two, either lithium aluminium hydride or sodium borohydride, then represent them by nascent hydrogen atoms and not molecular hydrogen atoms. Okay. Whenever aldehydes are reduced by either catalytic hydrogenation or sodium borohydride or by lithium aluminium hydride, these two atoms of hydrogens are added here, one on either side of the double bonded carbon and oxygen atoms. Then you will have R-CH2 CH2-OH. You will get a primary alcohol. Now if the same reaction is to be done using other reducing agents like lithium aluminium hydride or sodium borohydride, then also you need two hydrogen atoms, this time nascent hydrogen atoms, once here and the other time here. Again you will have RCH2OH. So reduction of aldehydes will give you primary alcohols. What happens if a ketone is reduced? Select a ketone, R, C, R, double bond O. A ketone is reduced under same conditions, either nickel or platinum or palladium. If these are reduced, again add one hydrogen here, the other hydrogen here. Then you will have R, C, R as it is here, H and OH. If this is properly rearranged, it looks like R, CH, OH, R. It is a secondary alcohol. Reduction of aldehydes gives you primary alcohol. Reduction of ketones gives you secondary alcohols if you are using reducing agents like lithium aluminium hydride, sodium borohydride, or catalytic hydrogenation. This is first reduction. Then the second reduction is reduction to hydrocarbons. this reaction is important of reduction to hydrocarbons. The second reduction is reduction to hydrocarbons. Under this, the first one is Clemence reduction. Clemence reduction. Because it is a named reaction, it is important in the exams. Now, what is Clemence reduction? For this, you take aldehyde and it is reduced using zinc amalgam. Zinc amalgam in presence of concentrated HCl. You may ask, what is amalgam? An amalgam is a mixture of at least two metals, out of which one should be compulsorily mercury. So when I have written Zn amalgam, zinc amalgam, this means it stands for mercury. Amalgam is a mixture of at least two metals. It can be a mixture of 3 or 4 metals also, but out of all the metals, one should be compulsorily mercury. So when aldehyde is reduced using zinc amalgam in concentrated HCl, it means zinc and mercury in presence of concentrated HCl. You write here ZnHg in presence of concentrated HCl. Then they get reduced. Who get reduced? Aldehydes get reduced. How? Our intention is to get hydrocarbons. So break one bond out of twice, break one bond, add one hydrogen here, one hydrogen here. So how many hydrogens are used? 2. Remember, you have to write here 2. Now if you write 2 hydrogens here, this is not a stable byproduct to go away. This will also be not a stable byproduct because you will have RCH2. So to make it stable, again reduce it, double reduction. So again add one hydrogen here, one hydrogen here. So total number of hydrogen atoms that you are using for reduction is 4. So when 4 hydrogen atoms are used for reduction, the product will be RCH3. RCH3 plus the other byproduct is H2O. So you now got a hydrocarbon as a product. What is Clemence reduction then? Clemence reduction means aldehydes or ketones are reduced in the presence of zinc amalgam and concentrated HCl, concentrated hydrochloric acid, to give corresponding hydrocarbons. This reaction is called Clemence reduction and it is an important question. If the same is given for a ketone, say RC double bond OR, if this is done, then under same conditions you break bonds here, you need 4 hydrogens, 2 hydrogens here, 2 hydrogens on the other side, then the product will be RCH2R plus H2O. You can try these with specific examples, like if it is an aldehyde, then you take CH3 CHO, break here, add 2 hydrogens here, 2 hydrogens here, the product will be CH3 CH3. You will get ethane. If it is a ketone like acetone, and if this is reduced, then 2 hydrogens here, 2 hydrogens here, then you will have propane CH3 CH2 CH3. A very easy reaction, and you are supposed to remember this because it is important for exams. It is a named reaction, therefore also important for competitive exams. This is Clemence reduction, wherein we use which reagent? Zinc amalgam and concentrated HCl. And what is amalgam? It is a mixture of 2 metals, out of which one is mercury. The second reduction under reduction to hydrocarbons, we have another named reaction, and it is Wolff-Kishner reduction. It is Wolff-Kishner reduction. In our previous session, we have seen addition reactions. Which addition? Nucleophilic addition reactions. Therein there was one reaction of addition of ammonia and its derivatives. Under these there were 7. If I am not wrong, there were 7 additions, out of which one was ammonia, then primary amine, then hydrazine, hydroxylamine, phenylhydrazine, 2,4-dinitrophenylhydrazine and semicarbazide. Out of all of these, now you remember hydrazine, its formula is NH2. Okay. Then react a given aldehyde in the first step of this reaction with hydrazine. How do you write hydrazine? NH2. When aldehydes or ketones react with hydrazines, then you eliminate this water molecule. Water is lost and what is obtained? RCH double bond N dash NH2. You will get corresponding hydrazone. Whenever aldehydes or ketones react with hydrazine, corresponding hydrazone is obtained. Now this hydrazone is heated with a base like either NaOH or KOH, any one among those, in the presence of solvent like ethylene glycol, which is a high boiling solvent. In the presence of ethylene glycol, either NaOH or KOH is chosen for heating. Upon heating, this would go to give you RCH3. See, RCH, add these two hydrogens here, it will become CH3 plus N2. This reduction is called Wolff-Kishner reduction. How do you write the statement form? Whenever aldehydes or ketones are reacted with hydrazine, corresponding hydrazones are obtained, which upon heating with KOH in the presence of ethylene glycol gives you alkanes or hydrocarbons. This reaction is called Wolff-Kishner reduction. This is also an important question because it is also a named reaction. Try the same with a ketone, RCR double bonded O. If it is reacted with hydrazine, under same conditions you will get the same kind of reaction. This goes, what remains? RCR double bond N NH2. Ketone hydrazones are obtained. Heated with KOH in presence of ethylene glycol, it will give you RCRH2 plus N2. Again you will get a hydrocarbon. So these two reactions, one is Wolff-Kishner reduction and the other is Clemence reduction. Both are important reactions for exams. So we have studied two chemical properties. One is addition reactions, the second is reduction reactions. Now we shall see the third chemical property. It is oxidation. You should be aware what oxidation is. Oxidation refers to addition of oxygen or else removal of hydrogen. So the third chemical property is oxidation. Oxidation of aldehydes and ketones. Let us compare how aldehydes and ketones undergo oxidation. If an aldehyde is oxidized, it is only a general representation, not correct technical reaction. If an aldehyde is oxidized, it will give you carboxylic acid. Aldehydes give carboxylic acid. Similarly, when a ketone is oxidized, it will also give you carboxylic acid. Then how are they different from each other? They are different from each other because oxidation of aldehydes is easy. It is easier to oxidize aldehydes than ketones. For oxidation of ketones, you need vigorous conditions. Vigorous conditions, these means either you may require high temperature or you may require presence of catalyst, etc., or you may need heating, you may need strong oxidizing agents. These conditions are required for oxidizing ketones. Whereas for oxidation of aldehydes, it is easier and it does not require any vigorous conditions. Rather, it needs mild conditions or mild oxidizing agents. Now, you may ask what kind of oxidizing agents? If you have strong oxidizing agents like acidified potassium dichromate or alkaline KMNO4, if you have these two reagents, these two are considered as strong oxidizing agents. Here also you need strong oxidizing agents. But for oxidation of aldehydes, even mild oxidizing agents are enough, like Clemence reagent. I'll tell you what Clemence reagent is, like Fehling's solution, etc. So oxidation of aldehydes requires mild oxidizing agents as well as strong oxidizing agents, whereas oxidation of ketones compulsorily require strong oxidizing agents and vigorous conditions like high temperature, etc. You may ask, sir, if ketones are getting oxidized by strong oxidizing agents, whether it is possible for an aldehyde to undergo oxidation by utilizing strong oxidizing agents? Yes. If a mild oxidizing agent can oxidize aldehyde, then obviously a strong oxidizing agent can also oxidize aldehydes to corresponding carboxylic acids. Then whenever aldehydes are oxidized, it gives you carboxylic acid containing same number of carbon atoms. The product carboxylic acid will contain same number of carbon atoms as present in the aldehyde, whereas if ketones are oxidized, it will give you less number of carbon atoms in the product. It will give you less number of carbon atoms. Say you have 4 carbon atoms in ketone, then the product carboxylic acid will not contain 4, but it will contain less number of carbon atoms. So you need to remember these differences. 1. Oxidation of both aldehydes and ketones gives you carboxylic acid. Oxidation of aldehyde requires mild oxidizing agents. Oxidation of ketones requires strong oxidizing agents. But it is also possible for a strong oxidizing agent to oxidize aldehyde to give corresponding carboxylic acid. Mild oxidizing agents cannot oxidize ketones. Like Clemence reagent, Fehling's solution, they do not oxidize ketones, but they oxidize aldehydes. Whenever aldehydes oxidize, they give you corresponding carboxylic acid containing same number of carbon atoms, whereas ketones upon oxidation will give you carboxylic acid containing less number of carbon atoms. If these points are clear, let us see the first oxidation reaction. It is a test called Clemence test. The first oxidation is Clemence test. Clemence test is a test devised by scientist Clemence. In this test, whenever aldehyde reacts with the Clemence reagent, I'll tell you what Clemence reagent is. Whenever it reacts with the Clemence reagent, I'll write this reagent, but it is not Clemence reagent exactly. When it reacts with Clemence reagent, it forms carboxylic acid along with precipitate of silver. This reaction is important because it is also done even in your practical exams. It is also asked in the form of a viva during your practical exam. You also perform this experiment in your regular practical classes. There is one experiment called detection of functional groups in organic compound. Therein, if you want to detect the presence of aldehyde in a compound, you carry out this test. How this test is done? For carrying out this test, you need Clemence reagent. What is Clemence reagent? I will tell you. Clemence reagent is ammonical silver nitrate solution. It is also a hot favorite question in exams. What is a tolerance reagent? If they ask you for 1 mark, your answer should be it is ammonical silver nitrate solution. How is it prepared? So you take sodium hydroxide, and add this to silver nitrate solution. It will give you silver oxide. Now this silver oxide is dissolved, it is dissolved in ammonia. It is dissolved in ammonia. It will give you a complex of this formula: diamine silver hydroxide. This is a tolerance reagent. If they ask you write the chemical composition of tolerance reagent, you are supposed to write this formula. It is diamine silver hydroxide. You need not remember the preparation method, how you prepare this tolerance reagent, but you need to remember tolerance reagent is technically, chemically, it is ammonical silver nitrate solution. Its chemical formula is AgNH3 twice OH. How is it prepared? It is prepared by first adding sodium hydroxide to silver nitrate, which gives you a precipitate of silver oxide, which is then dissolved in ammonia to get ammonical silver nitrate solution, or commonly called tolerance reagent. For the sake of simplicity, out of all these formula, only this much part participates in the reaction. For the sake of simplicity, tolerance reagent is written as Ag2O. So if in the exam they ask you what is tolerance reagent's chemical formula, do not write Ag2O. It is not the exact composition, this is the exact composition. Understood? For the sake of simplicity, only to make you understand how it undergoes oxidation and gives you the reaction, I have written Ag2O as the chemical formula, which is not the exact formula of tolerance reagent. Now, when tolerance reagent reacts with given aldehyde, it gives you carboxylic acid and silver gets precipitated as a black precipitate, or else it will give you a silver mirror. You may ask what a silver mirror is. You carry out this test in the lab in this way. You take given compound, to this you add tolerance reagent and keep it in water bath. To a given test tube, you add the given compound, then you add tolerance reagent. What is tolerance reagent? Ammonical silver nitrate solution, and shake them, keep them in water bath. Water bath means any container containing water kept for boiling or heating for 5 to 10 minutes. After 5 to 10 minutes, you observe inside the test tube, your white colored solution, which was earlier due to this mixture, has now turned into a black precipitate due to deposition of silver, or else on the inner walls of the test tube, you will see that a silver mirror has formed. Silver has deposited on the inner walls of test tube. This will confirm the presence of aldehyde. Ketones do not react with this reagent. Only aldehydes show this test. So by oxidation method, which oxidizing agent? By tolerance reagent, it oxidizes only aldehydes and not ketones, because it is a mild oxidizing agent. Then we have second reaction, it is Fehling's test. I'll first write the reaction and I'll then explain. Again, aldehyde reacts with Fehling's solution to give you carboxylic acid and precipitate of cuprous oxide. How this test is done? Even this is done in the regular practicals. For carrying out this test, you need two solutions prepared by scientist Fehling. One is called Fehling's solution A. In some books it is given as Fehling's solution 1. Again, there is one more solution called Fehling's solution B or Fehling's solution 2. Fehling's solution 1 is called as alkaline copper sulfate solution. It is alkaline copper sulfate solution. It is actually copper sulfate dissolved in sodium hydroxide. This is called first solution, first Fehling's solution. The second solution is sodium potassium tartarate. Sodium potassium tartarate solution. It's a chemical compound. Sodium potassium tartarate is otherwise called Rochelle's salt. It is also called Rochelle's salt. Its solution is prepared. Now remember, Fehling's solution 1 or Fehling's solution A is blue in color, sky blue color. Then Fehling's solution B, it is colorless. Now why I am telling you this is, you will have a sound idea of how to carry out this test. To a given test tube, you add the given compound, then you add equal quantities of Fehling's solution 1 and 2, Fehling's solution A and B. First you will add Fehling's solution A, which is sky blue in color, then you will add Fehling's solution B, which is colorless in color. When these two are added, your mixture will turn into dark blue. Keep this test tube in a water bath again for 5 to 10 minutes and observe the change in color. The bluish color solution will now change into reddish precipitate. If not red, it can give you orange red or brownish precipitate. It is due to precipitation of cuprous oxide. You may ask, sir, if they ask what Fehling's solution is, can I write this formula? No, again no. This is only for the sake of simplicity. For you to understand, I have combined both the solutions of Fehling's and represented it as CO. It is not the formula of Fehling's solution. And moreover, they will not ask you Fehling's solution formula because it is not there for your syllabus. But you need to remember, Fehling's solution is a mixture of two solutions, A and B. A is alkaline copper sulfate solution, B is sodium potassium tartrate. When it is mixed, blue color changes to red due to the deposition of cuprous oxide. Then the last test, we have one more oxidation. You need to remember that Fehling's test is only done for aliphatic aldehydes. Even aromatic aldehydes do not respond to this test. In Tollens test, only aldehydes respond to Tollens test. In Fehling's test, only aliphatic aldehydes react, aromatic aldehydes fail to answer Fehling's test. The third is oxidation of methyl ketones. Now you may ask, sir, we know what ketones are, but what are methyl ketones? Methyl ketones are those in which one of the alkyl groups is compulsorily methyl group. So these are methyl ketones. Whenever methyl ketones are reacted with sodium hypohalide, NaOX, sodium hypohalide. So when they are reacted with sodium hypohalide, they will give you a salt and haloform. They will give you haloform and a salt. You need not bother about how to balance this reaction. It is not required. This reaction is shown only by ketones and not by aldehydes. So you have studied 3 oxidation reactions. One is by Tollens test, which is done only for aldehydes. Ketones do not show this test. The second is Fehling's test, in which aliphatic aldehydes answer this test. Even aromatic aldehydes and ketones do not respond. The third is oxidation of methyl ketones, wherein methyl ketones are those ketones in which at least one of the alkyl group is a methyl group. Whenever methyl ketones are oxidized in the presence of sodium hypohalide, you will get haloform as the product. In this session, we have studied 2 chemical properties. The first one was nucleophilic addition reactions done in the previous session. In today's session, you have studied reduction and oxidation. In our next session, we shall see some more chemical properties of aldehydes and ketones. Thank you.